Welcome to new session of the differential equation. In this session we discuss solving differential equation by variable separable method. As we discussed before, the solutions of first order ordinary differential equation. See, we have one variable function y is equal to f of x. So, corresponding that we have a derivatives dy by dx and d square y by dx square etc. are the different order derivative. The derivative first order derivative, the differential equation which involve the first order derivative only is called first order differential equation. So, we have many types of the first order differential equation. Among that we can have some differential equation of the type g of y into dy is equal to some f of x into dx. That means we can separate the variable like this. Maybe some types of differential equation is like that, dy by dx is equal to f of x divided by some g of y maybe, or sometimes we can say that dy by dx is equal to some g of y into f of x. Maybe in either case no problem, we can separate the variables. So, if there is a differential equation, first order differential equation of this type, we can simply solve this differential equation by integrating both sides. So, we will integrate both sides. So, while integrating both sides, we will have the differential equation of the form, this is integral some g of y into dy is equal to integral of some f of x into dx plus c, integral of some f of x into dx plus c, where c is the arbitrary constant. After integrating this, we will get a curve or a function in x and y. Maybe implicitly or explicitly we will get a function. So, that is the solution of the differential equation. See, if that is the solution of the differential equation, because of this arbitrary constant c, that solution is called a general solution. If we give the particular values for c, we will have a particular solution. Sometimes maybe some initial condition will make given. So, like that if maybe some y of 0 equal to 1, or simply we can say that some y of x naught equal to y naught. This is the value of y whenever x is equal to the initial point of the domain x naught. So, if we apply this value to the solution, we will get a particular value for c. On that case, we will get a single solution, that is a unique solution. That solution is called a particular solution corresponding to that initial value problem. See, we can move to some problems. Solve the differential equation, first order differential equation 10y dash plus 3x is equal to 0. We put this as equation number 1. Okay, we put this as equation number 1. So, here we have 10y dash is equal to plus 3x is equal to 0. We took this 3x to here to RHS. So, we will have 10y, I would like to write dy y dash as dy by dx equal to, instead of 3x we have minus 3x is here. So, we have, I would like to take this is to here, dx to here, therefore, we will have 10y dy is equal to minus 3x dx. As I said just before, we discussed it is that if we separate variables like this, some g of y into dy, a function of y into dy is equal to a function of x into dx, then it is the variables are separated. So, we can apply variable separable method on that case. So, we separated some 10y into dy is equal to minus 3x into dx. So, we can integrate both sides. So, integrating both sides, integrating both sides. Therefore, we will have integral of 10y dy is equal to minus integral of 3x dx plus c. Okay. So, we have 10y dy, integral of 10y, that is integral of y is y square by 2. Therefore, 10 y square by 2 is equal to integral of minus integral of 3x square by 2 minus 3x square by 2 plus the constant of integration is there, c is there. See, we can rewrite this as 10y square by 2, we can cancel 10 and 2, we will have 5. 5y square is equal to minus 3x square by 2 plus c, minus 3x square by 2 plus c. This is the solution, general solution. Maybe if we need, we can just rewrite this as 5y square minus 3x square, we will take minus 3x to, x square to LHS. So, we will have plus 3x square by 2 is equal to c. Okay, plus 3x square by 2 plus c. Okay, therefore, this is the general solution. Is the general solution of given differential equation, is the general solution of the given differential equation. See, we can just move to one more question. Next question. Solve the ordinary differential equation. Solve the ordinary differential equation. Solve the ordinary differential equation. Y dash is equal to 1 plus y square. Y dash is equal to 1 plus y square. That is dy by dx is equal to that is dy by dx is equal to 1 plus y square. So, we just dx to right side and 1 plus y square into denominator of the LHS. So, we will have dy divided by 1 plus y square is equal to dx. Now, we separated the variables, because as we separated the variable, we can integrate both sides. So, integrating both sides, Therefore, we will have the integral of dy divided by 1 plus y square is equal to integral of dx plus c. See, this is integral of 1 by 1 plus x square is the tan inverse of x. So, integral of 1 by 1 plus y square is tan inverse of y. So, we will have this is equal to tan inverse of y is equal to integral of dx, that is the x. So, integral of dx is the x plus c. Okay. So, we can write this as tan inverse of x is, y is equal to x plus c is the general solution, of given differential equation. This can be write as, we can take the tan inverse to RHS. Therefore, we will have, that is, we can write this as y is equal to tan inverse of x plus c as tan of x plus c. Okay. This is also the general solution. Okay. Fine. This is also the general solution of the given differential equation. See, I would like to move to one more question, the question number 3. Solve ODE, the ordinary differential equation. In this differential equation, we have dy by dx plus 2xy is equal to 0, dy by dx plus 2xy is equal to 0. Okay. This is the differential equation 1. Okay. So, we can take this as dy by dx plus 2xy as dy by dx we can take this 2xy to RHS, therefore, that is equal to minus 2xy, okay, is equal to 0, therefore, dy by dx is equal to minus 2xy. See, we can take this y to here, therefore, this is equal to dy divided by y is equal to minus 2x dx. Fine. Now, we separated the variables. So, we can apply, we can integrate both sides. So, integrating both sides. So, we have integral of dy by y is equal to integral of minus 2x, that is minus 2x minus 2 into minus of integral 2x dx plus c, the constant of integration is there. Okay, fine. While integrating dy by y, we have the formula integral of 1 by y, that is equal to log mod y. Therefore, this is equal to log mod y is equal to see integral of minus 2x, that is equal to minus 2x square by 2 plus then the constant of integration is there. Therefore, c is there plus c. Okay. So, we have this is equal to log mod y is equal to we can cancel this and this, therefore, minus x square plus c is there. Okay, fine, and we can take an exponential function on both sides. So, we will have e raised to log mod y is equal to e raised to minus of x square plus c. Okay, e raised to log mod y, we have e raised to log mod y is equal to y itself, y is equal to e raised to minus x square into e raised to c. Okay, we can rewrite this as y is equal to some c1 e raised to minus x square, some c1 some c1 e raised to minus x square, where c1 is equal to e raised to c, where c1 is equal to e raised to c. So, this is the general solution of the given differential equation. See, y is equal to c1 e raised to minus x square is the general solution of given differential equation. See, all these cases what we did is there, here we have a differential equation, we are checking whether it is possible to separate or not. So, we are checking by taking to one term to opposite sides. So, because of that we are able to separate the variables, one side fully contains the terms of y, the opposite side the RHS will contain the terms in x only. So, we can integrate both sides, we will have the solution like this. We can manipulate and we can reduce the solution, we will have a solution in the very fair form. As I said to you before, if it is a initial value problem, if it contains an initial condition, then we are able to find out a particular value for C1 or C. Therefore, we will be able to find out a constant value. We can just move to another question, that is question number 4. In question number 4, we will discuss an initial value problem. Solve the initial value problem, solve the IVP, the initial value problem. Initial value problem is actually a differential equation. Ay dash is equal to b minus ky with the initial condition y of 0 equal to 0, that is value of y is equal to 0 whenever value of x is equal to 0. So that we can solve this, that is this is equal to a into y dash is dy by dx we have, and this is equal to b minus ky. Okay. we can take dx to this RHS side, and we can take b minus ky into denominator of the LHS. Therefore, we will have a divided by b minus ky, a divided by b minus ky into dy is equal to some dx. Now, okay, we are happy we separated the variables. We separated the variable. Now, we have a divided by b minus ky is the term containing only the variable y. Here the x only. Now, we can integrate, integrating both sides, integrating both sides. So, we have integral of a divided by b minus ky dy is equal to integral of dx plus c. Okay, integral of a divided by b minus ky, integral of a divided by b minus ky into dy. Okay, put u is equal to b minus ky. Therefore, we differentiate with respect to y. Therefore, du is equal to minus k dy. So, we can take to minus k to here, du divided by minus k is equal to dy. Okay. So, we can rewrite this as this is equal to integral of a into integral of 1 divided by b minus ky as u, du divided by minus k is there. So, we can take minus minus a divided by k integral of 1 by u du. Okay, integral of 1 by u du. We can have, we know that integral of 1 by u du as a log. Okay, therefore, we can write this as minus a by k log mod u. Okay, minus 1 by k log mod u. We can replace u as u is equal to b minus ky. Therefore, this is equal to minus a by k log mod a minus log mod a minus ky, log mod a minus ky is there. See, my dear students, minus a by k log mod a minus ky is the value of integral of a divided by b minus ky into dy. See, so that we can write this as this is equal to, actually you have integral of a divided by b minus ky dy. The value is a minus a by k log mod of a minus ky. Therefore, this is equal to minus a by k log mod b minus ky, fine, and minus a by k log mod b minus ky. Just try replace this as b minus ky. Okay, minus a by k log mod b minus ky. This integral of dx is x plus c. So, this is equal to integral of dx is x plus the arbitrary constant c is there. So, fine, we can replace the values. Okay. Fine, we can replace the values as this is equal to minus a by k log mod b minus ky. See, we have initial condition is here. We have initial condition as y of 0 equal to 0. So, since y of 0 equal to 0, we can write this as we have y of 0 equal to 0. Therefore, we can apply y is equal to 0 when x is equal to 0. So, instead of y we can apply the 0, instead of x we can apply 0. Therefore, we rewrite this as this is equal to minus a by k. I put this is the equation number 2. So, equation number 2 becomes, we can say the equation number 2, equation 2 becomes, okay, we just apply the y is equal to 0 and x is equal to 0 in this equation number 2. Therefore, this is equal to minus a divided by k log mod b minus ky, y is equal to 0, therefore, ky is equal to 0, log mod b is equal to x is equal to 0, therefore, 0 plus c. That is c is equal to minus a by k log mod b, minus a by k log mod b. So, equation 2 we found a value for c in equation 2. So, we apply into, put into, therefore, 2 becomes as, equation number 2 becomes as minus a by k log mod b minus ky minus a by k log mod b minus ky minus a by k is equal to x plus value of c, x plus the value of c as minus a by k log mod b, minus a by k log mod b. Okay. So, while taking this is to here, we will have this implies minus a by k while taking minus a by k to here plus a by k log mod b minus a by k log mod b minus ky is equal to x. Okay. Therefore, we can log mod b minus ky, log mod b minus ky. Okay. Therefore, we can take a by k to out, log of b minus ky, that is equal to log b by b minus ky is equal to x. Okay. Fine. Therefore, we can write this as log mod b minus ky by x. Okay. So, if we take this is minus to be here minus a by k, we can write this as minus a by k log mod b minus ky divided by b is equal to x. So, we can write this as minus a by k, this implies minus a by k log mod 1 minus ky by b log 1 minus ky by b is equal to x. See, this is equal to, we can write this as a by k to here log 1 minus ky divided by b is equal to minus k by a x. Okay. Taking exponential function on both sides. Therefore, we can write this as e raised to log 1 minus ky divided by b is equal to e raised to minus k by a x. Okay. So, we can rewrite this as, this implies e and log is there, therefore, 1 minus ky by b is equal to e raised to minus k by a x. Okay. So, we can write this as, this implies k y by b is equal to, we took this is to here, this is to here and this is to here, 1 minus e raised to minus k by a x is there. Okay, fine. So, that we can we just keep the y is only there. So, we have y is equal to, sorry, we have y is equal to, therefore, y is equal to, therefore, y is equal to, therefore, y is equal to, we took b by k to here, therefore, we will have b by k, therefore, we will have b by k and 1 minus e raised to minus k by x, 1 minus e raised to k by a, e raised to minus k by a x. Okay. So, this is the particular solution of the initial value problem. So, is the solution of given initial value problem. Okay, fine. Therefore, as we said before, if there is an initial value problem, there should be an initial condition is there. So, here we have the initial value problem. In this initial value problem, we have the initial condition y of 0 is equal to 0 is there. We separated the variable, we performed the integration on both sides, and after performing the integration on both sides, we will have integrating both sides, we will have the general solution as like this. The general solution as like this. We have the general solution as like in equation 2. So, to find the value of C, we just apply the initial conditions are there, y of 0 equal to 0. That means y is equal to 0 whenever x is equal to 0. So, equation 2 become, from here we found C and we will apply into 2. So, we will have a particular solution. By reducing and manipulating this, we found that the general solution as, the particular solution as y is equal to b by k into 1 minus e raised to minus k by ax. So, this is a very nice part of the differential equation. I would like to give you some assignments in this from this part. Solve the following ordinary differential equation by variable separable method, by VSM method, variable separable method. The first one is dy by dx is equal to 1 plus y square divided by 1 plus x square, 1 plus y square divided by 1 plus x square. Okay. This write down the second assignment question as dy by dx is equal to x plus 1 divided by 2 minus y, x plus 1 divided by 2 minus y. Write down the third question, solve initial value problem, dy by dx minus y tan 2x is equal to 0 with the initial condition y of 0 equal to 2. Try to solve these 3 assignment problems. You will clearly understood about variable separable method. This is a very nice and interesting method on the differential equation. You can find many questions from the literature to solve the differential equation by using variable separable method. Try to solve such all questions, that will be give you a very much motivation on this area. Okay. Thank you for watching. Continue watching. Thank you very much.